Hello, boys and girls. Welcome back to Math with Miss Wardell. We are in lesson 25. This is a problem set of module 5. It is on page 105. Lesson 25 in module 5 on page 105. All right, we have been talking about expressing whole numbers on a number line using fractions, and we're going to continue to do that when looking at whole numbers. So number 1 says label the following models as a fraction inside the dotted line or dotted box. The first one has been done for you. So here, this is our key. This means that this equals 1 whole, okay? This equals 1 whole. So here, I have 1 whole. It's partitioned into 1, 2, 3. So 3 parts. And the parts that are shaded, 1, 2, 3, is 3. So this equals 3/3, or 1 whole. Again, I have here's a whole, here's a whole. However, notice they're partitioned into how many parts? 1, 2, 1, 2. So my fraction is going to be in halves, so over 2. And the part that is shaded is 1, 2, 3. So my fraction is 3 halves. All right. This one is pretty fun. I like this one a lot. So going back and looking at our key, notice that this is 1 whole. It's not partitioned at all, is it? No. However, how many are shaded? 1, 2, 3. So if I write a whole number as a fraction, because this is essentially 1, 2, 3 wholes, I could say this is 3 over 1. Okay, so that tells me it's 3 wholes. Here we have a whole. It's partitioned into 4 equal pieces. 1, 2, 3, 4. Remember, partitioning meaning to break apart into equal pieces. And they've got 4 that are shaded, so 4 fourths. Again, 1 whole. Here I have a whole and a whole. It's partitioned into 1, 2, 3, 4. Or 1, 2, 1, 2, sorry. So I have halves. And I have 1, 2, 3, 4. I have 4 halves that are shaded. Alright, much like this one up here, I've got 1, 2, 3, 4, 4 wholes. And remember, we said that we could represent that as a fraction using 4 over 1, because it's 1 whole. It's not partitioned into anything. It's just 1. Alright, the last part here, it's partitioned into 1, 2, 3, 4, 5, 6. 6 pieces, and I have 6 of them that are shaded, so my fraction is 6/6. Again, that's 1 whole. Here I have 1, 2, 3, 1, 2, 3. So they're divided into thirds, but I have 1, 2, 3, 4, 5, 6 of them that are shaded, so 6/3 are shaded. And another whole number here, and so I've got 1, 2, 3, 4, 5, 6. So I can represent that by saying 6 over 1. 6 over 1. Awesome. Turn over to the next page, page 106. On the back it says, fill in the missing whole numbers. In the boxes below the number line, rename the whole number as fractions in the boxes above the number line. Okay, so we can do that. So it's asking us to represent the whole number as a fraction, just like we did here, here, and here. So I'm going to say 0 over 1, 1 over 1, here's 2 over 1, 3 would be 3 over 1, this is any whole number, 4 over 1, 5 over 1, and 6 over 1. So representing each whole number as a fraction. Okay? On the bottom part, not only are we looking at and still naming the whole numbers, but now we have to put in the whole numbers below it, right? So 10 over 1 would be 10. 11 over 1 would be 11. Oh, we have the whole number. Now we need the fraction. So 12 would be 12 over 1. 13 would be 13 over 1. Here we have the fraction 14 over 1, so my whole number here would be 14. The whole number 15 would be 15 over 1 as my fraction. And the last one, 16, would be represented as 16 over 1. Okay? Not so hard, is it? Last one says explain the difference between these two fractions with words and pictures. Alright, so we're talking about 2 over 1, which we know that 2 over 1 equals 2. Yes? And we know that 2 over 2 equals 1. So 2 over 1 means that there are 2 wholes in the unit. Okay? So 2 over 1 means there are 2 wholes and the unit of each is 1. So let me say that again. 2 over 1 means that there are 2 wholes and the unit is 1 because it has not been partitioned at all. Two over 2 means there is 1 whole. Okay, that means there's 1 whole. So one last thing that I'm going to do, I'm going to say this little square equals 1 whole. Okay? I'm going to represent 1 whole again by showing that same square, dividing it into 2, and filling in each part. So this again is 2 over 2. That's a great way to show that one. When I'm talking about 2 over 1 here, I'm talking about having a whole and another whole, right? And saying that both of these equal 2 over 1. Okay? Both of those equal 2 over 1. So that means that I have 2 wholes. I have 2. because they are not partitioned into any equal parts. They're just one whole. Alright guys, I'll talk to you later, and see you next time. Goodbye.